It's new product time, Lady Ada. New product. Okay.
New.
First up, we have a new video that went with our product launch last week, Pro Trinket. And Pro Trinket, I would ask you to explain what it is, but instead, I'm going to have past you do it.
Just watch this video.
Ready?
Hey everybody, it's me, Lady Ada. I'm at the Adafruit factory here in Manhattan, and I'm here to talk to you about another new design I just finished, the Pro Trinket. Pro Trinket is the update to Trinket. It's got everything you love, plus Arduino, squished into one delicious package. You may already be familiar with the Adafruit Trinket. It's a board we designed about a year ago. It's meant to be a small, easy to use, and low-cost microcontroller board for your small projects. But some people want to build something a little more complicated. So now we have Pro Trinket. Pro Trinket has 4 times as many pins and 4 times as much flash, so you can build much more complicated and elegant projects. This is the classic Trinket. It's based on the ATtiny 85 AVR microcontroller. This microcontroller has 5 I/O pins, 8K of flash, and a half a K of RAM. In comparison, this is the Pro Trinket, which we based off of the Atmega 328 processor. This processor has 32K of flash and 2K of RAM and 18 I/O pins. So it's about 4 times as much everything. It's got a lot of horsepower. If the processor on the Pro Trinket sounds familiar, that's because it's the same one used in the Arduino Uno, the Atmega 328. This means that the entire ecosystem of Arduino compatible sketches and libraries work seamlessly on the Pro Trinket. Design your prototype on the classic Arduino Uno. Once you finish your project, you can load the same code into your Pro Trinket. That way you can miniaturize your project. Pro Trinket comes in 2 flavors. We've got the classic 5-volt 16 megahertz version. This one is most like an Arduino Uno. And we've also got, for power users, the 3-volt 12 megahertz version. This one is good for people who need 3-volt logic or runs on battery and don't mind that it's a little bit slower. Solder header to the bottom of your Pro Trinket to make it breadboard friendly. This way you can prototype projects, like this GPS plus OLED display. There's 2 ways to upload code to your Pro Trinket. The first is using the onboard micro USB jack. This allows you to upload code through the Arduino IDE, but since there's no USB serial chip on board, it doesn't provide you with a debug console. The second method is to use an FTDI cable. You can use any FTDI cable or FTDI friend. This allows you to not only upload code through the cable, but since there's a USB to serial converter chip inside the cable, it also gives you a debug console. Each Pro Trinket is designed, engineered, manufactured, and shipped out of the Adafruit factory here in downtown Manhattan. Do you have a project that could use an Adafruit Pro Trinket? I'm pretty sure you do. If so, pick one up today at the Adafruit web shop.
Okay,
Trinket was like 9 months in the making, so I'm glad that it was finally birthed from my brain. Because we started it in September, and I just kept taking forever to finish it. But it's done, it works really well, I really like it, and we're going to be using it in a lot of projects. There's a lot of stuff that I wanted to do with Trinket, but Trinket couldn't handle it, didn't have enough memory or enough pins. So you'll probably be seeing a lot of more complicated mini projects with Trinket, and hopefully other people as well. It's been popular. We sold out in a couple days.
Next up, we've got a new GoPro camera holder.
Yeah, you like this. You ordered this. What's your thoughts here?
Okay, so here's the thing.
You got this thing.
Yeah, so this is from a company that a lot of people know.
Yeah.
The folks who make the...
Yeah, it's Panavise.
Yeah, the Panavise. If you like the quality of Panavise, and you probably have one, we use them here all the time. Here's the one that's permanently on the Ask an Engineer desk. If you like that type of quality and product,
this is intense suction.
Yeah.
I feel like lifting entire table.
Yeah, don't do that.
I don't know how to do that. It's got a suction cup?
Yeah, it's a suction cup. So this, I'll go back to the photos of it, but this will mount a GoPro, and it just has the same quality and durability.
It's really intense.
As a Panavise.
It's like half metal, half cast, and then resin.
Here, you can put it underneath the overhead for a second and kind of show it around.
Yeah, you've got adjusting knobs, and then this killer suction cup, which is there's a releaser because it's so powerful, or a compressor. Wow, there's even that's cool. There's these holes. I don't know. Anyways, and this is your GoPro camera.
Yeah.
Yeah, so it's just like a really intense GoPro mount. You could probably use it for other stuff. Does it have a generic camera mount, or is it GoPro only?
This one is GoPro.
Okay, this is GoPro.
But you could also...
Well, we're using GoPros all the time for our videos and stuff.
Yeah, so if you want to mount this to your workbench, or if you want to mount it to like anything...
Oh, you can do like a time lapse or something.
Anything where it's hard to get a tripod or something like that. It's great. Tried it out, really liked it, decided to put it in the store.
Okay, good enough for me.
Yeah. Next up. This is interesting.
These are weird.
These are weird. I've not seen these anywhere.
No, this is really unusual, but I thought they were kind of interesting, and they're really low cost. I mean, it's not like the most useful thing, maybe, but I think that there's probably uses for this that I don't completely know yet. But like once I see them, I'll be like, wow, this is the most useful thing. They're basically just this is like the most basic breadboard. It's just like a strip of pins, and I'll show the bottom of them because actually that's where the action is. Yeah, so you can see it's basically like a little breadboard strip where you have like 8 or 4 pins, and then you can have 8 or 4 rows with 2 pins each. So I just showed them like if you wanted to add a little piece of breadboard to a Proto.
Yes, I can go to the overhead.
Thanks. So like I have a Proto, and you can solder this in and then create a little mini breadboarding area if you wanted to. You can also use socket, but this is maybe like a little more elegant to use. And you can stack them up next to each other. So I mean, they're little breadboard pieces. Also, like sometimes you maybe don't want to use you want to just attach like wires or chips or LEDs to a Proto or like a Proto shield or something. It might be handy. They have little bumps on the bottom, but you can cut those off. I don't know. I think it's interesting. Little mini breadboards.
Yeah.
I'm at a loss because I don't have like a super excellent reason for this. I just thought they were interesting. But you know what?
Yeah.
Sometimes I carry stuff that I just think is interesting, and other people are like, "Yeah, you're right. That's like really interesting."
Yeah, I think if you did if you used a Proto and you had like a permanent part of your project, but then you wanted to have one part where you just wanted to do a lot of different testing and stuff like that. That's the way I'd use it.
Yeah, that's basically what it is.
You have one part of your circuit you're done and finished with, another part you just want to do experimentation.
Yeah, like you want to swap out different LEDs.
Yeah.
Another thing about like socket header, like you're like, well, I could just use female socket header, but the socket header, it doesn't quite grip as well as the breadboarding chunks, which have like a really strong spring, and you can use almost any gauge wire. So for that reason, like you may want to try this instead.
Okay, next up.
Next up.
As I was saying before, we have filament.
Filaments.
So right now we have black, silver, white, and gray.
Black, silver, white, and gray in ABS, PLA, and 1.7 millimeter and 3 millimeter.
Yeah.
So basically, like every kind, every combination of ABS, PLA, 3 millimeter, 1.75 millimeter in 3 colors, and we will add more colors, but we were starting with Adafruit colors, Adafruit black, and then desaturated Adafruit black, and all the way desaturated Adafruit black.
Okay.
So yeah.
So let me tell you about this and why we chose this one.
Why did you choose this?
Yeah, I just updated the product page.
Okay.
So why do we choose this over the other options? We sampled filaments from dozens of trusted 3D filament suppliers and tested them out on our fleet of 3D printers. We actually have a fleet of 3D printers. Several options worked okay, but we found Ultimate Machine's range plastics are the most consistently reliable in terms of printing and spooling, and we've switched to using this filament for all of the Adafruit prints. So some people have asked, how do your prints look so good? This is what we've been using. The other thing is, if you had to decide on what to look for in a filament, it shouldn't clog. It has to be reliable diameters. That's one of the things.
It's just unspooled and I can't
free
get
of
caught.
Free of imperfections. It arrives in a plastic bag, so there's no humidity issues. The spools are not tangled up at all.
Yep.
And the sides of the spools are compatible with a lot of different types of 3D printers.
Yeah.
The raw materials that they used is from NatureWorks. It's PLA 404 3D, indigo resins created from corn grown in the U.S. The pigments used are also bio-friendly, and this is for PLA, specifically for PLA. So
we like this filament.
Yeah.
We hope you do too.
So
We've
that's
heard no complaints from people about this filament, and like we had a really smooth time printing it, and like we've been printing stuff that takes 49 hours. So if the filament isn't good, like you really don't want to get into like a multi-day print.
Our next project is a project that took days to print.
Days.
Okay. So next up, we have an update of an Adafruit Classic.
classic. This is like product like 75 or something. This is the Proto Shield Rev 3. And it took me a while to get around to it, but then we finally ran out of Proto Shield PCBs. Like we ordered enough for like a year because they were so popular. And then we're like, oh man, I ran out. I'm like, I should really revise it. So we revised it, and because like we bought some and we could even lower the price. This shield is an upgrade. It now adds. It comes with stacking headers, which is great. Stacking headers didn't exist when we first had the Proto Shield, but now they do. So you can stack them. We enlarged the holes a little bit on the Proto Shield, and we made it R3 compatible as well as fully stacking compatible. So you can use this with any shield and pretty much any Arduino, and I will show some examples of stacking if you would like to go to the overhead. Yeah, and this just shows you like, oh look, I have like stuff on it. Proto area, very good. And this is a video of the little animated GIF.
Okay.
So this is the assembled Proto Shield, and so yeah, we have stacking headers. There's a little area for surface mount chips, but it's now fully stacking. It's got the 6-pin stacker over here, and it's got full stacking headers, so you can plug it into any kind of Arduino, like Uno, Dominove, Leonardo, Mega, Due, whatever, and it works quite well, and it stacks through all the parts, so you can stack any shield on top of it. If you're using like an Arduino Ethernet or YUN, which I have here, one thing that's it's not bad, but just watch out for is the Ethernet jack and the USB jack are taller than the USB jack on the, so you can see it's like 3 millimeters taller. So you can stack this shield on top of it, but it just doesn't sit like all the way down. You can only stack, it sits, but it's like, it kind of leans up a little bit. Maybe not a problem for you. I mean, all the pins still make contact. It doesn't sit as flat. So it's a little bit of a trade-off, but it does work. And yeah, you can basically stack as many of these shields as you want. You have a big prototyping area here. You can have chips, you have power rails, you have some LEDs and buttons. It's kind of a generic Proto Shield, but it works very well. It's one of our classics and most beloved.
Here's the question. Is the Proto Shield at all related to Make's Proto Shield? No, Make's Proto Shield came out way later.
Yeah, we've had this Proto Shield for a very long time.
Yeah, I'm pretty sure the Maker Shield's based on our design.
I think they used some of the ideas and they added some more stuff. Yeah. I like the Maker Shield. It's nice. It's a very nice design. I just kind of like my classic design a little bit more. Also, I don't know if they upgraded theirs to R3, but I kind of was getting annoyed when I'm like, man, like those
we had to do
R3 pins aren't there.
Okay, next up.
Okay.
This is a big one. And I like to call this a category product because forever, 3 Maker Fairs ago, when this is a 3-year project.
I know, I'm sorry.
This is the battery shield, but we're also calling it the PowerBoost shield. Now, before you get going into this,
I'm not going to do it.
Before you get going into this, we have a video about our PowerBoost series.
Oh, that's right.
Yep.
Let's watch that video.
Yep.
Okay. Hey everybody, it's me, Lady Ada, here at the Adafruit Factory in New York, and today I'm going to show you how you can portabilize your project using Adafruit PowerBoost. The PowerBoost family solves a common problem that you've probably experienced in electronics, where you want to run something that really wants 5 volts off of something that only gives you maybe 3 or 4 volts. We've cooked up PowerBoost in 2 flavors. We've got the rechargeable version that uses rechargeable lithium-ion or polymer batteries, and the non-rechargeable version that can use any kind of batteries. Let's talk about these kinds first. For most projects, you can get away with using the PowerBoost 500. This booster can supply at least 500 milliamps at 5 volts. For power-hungry projects, you may need the PowerBoost 1000. This booster can give you at least 1 amp at 5 volts. To power your PowerBoost, you'll need to connect up a battery. You can use any kind of battery with 2 to 5 volts output. For example, a rechargeable lithium-ion or polymer battery, or a couple AA's or AAA's. You can use rechargeable or alkaline. Once you've picked your battery, just plug it in and look for the power light. Once you've got the battery connected to the PowerBoost, you can use any USB cable to power your project. Now you're ready to glow. You can even use it to power your phone. Each PowerBoost has a low battery indicator LED that lights up red when the input batteries drop below 3.2 volts. This lets you know it's time to recharge or replace your battery. For really power-hungry projects, you may want to upgrade to the PowerBoost 1000, which can provide an amp or more of current. This is good for big projects that use a BeagleBone or a Raspberry Pi. It can even charge up tablets. Now we're on to the rechargeable PowerBoosts. This is the PowerBoost 500C. That means it's a PowerBoost 500 plus some lithium-ion charging circuitry over here. That means you can only use lithium polymer or lithium-ion batteries with this PowerBoost. You can charge up the battery by plugging any micro USB cable in, connected up to a wall adapter or computer. There's two charge LEDs. When the yellow LED is lit, it means it's charging. When the green LED is lit, it means it's done. If you like the PowerBoost 500C and you're using it with an Arduino, you may be interested in the PowerBoost Shield. It's kind of like a PowerBoost 500C, but in Shield format. You've got the same PowerBoost 500 circuitry and the charging circuitry as well, but you can stack it onto an Arduino and fit a battery inside the Shield. Then stack whatever other shield you like on top. It even gives you an on-off switch so you can glow on the go. Each PowerBoost is designed, engineered, manufactured, and shipped out of the Adafruit warehouse in downtown Manhattan. Next time you need to take your project on the road, pick up one of these fine Adafruit PowerBoosts at the Adafruit shop. Okay, thank you last week.
All right. Yeah, so we have some photos of it, and we have it in action.
Yep.
This is one of the coolest shields because so much had to happen for this to work out. From the great batteries that we have, to all the manufacturing equipment, to all of the things that go along together perfectly with it. And you did a really good job on this.
Yay.
I know you've been working on it for a long time. So do you want to show this on the overhead?
Yes, I would.
Okay.
So here is the shield, and I just it's a stacking shield, and I just put it onto an Arduino Uno. And yeah, you have a little spot here. You can put a battery in it, and it's perfectly sized for our 1200 milliamp hour battery. We're also getting a 2000 milliamp hour battery, which isn't here yet. It's a little bit thicker, but also fits in here. But for now, 1200 is fine. I'll run your project for a couple hours at least. And the battery plugs into here, and then all the circuitries are on the side, so it's all safe and protected. It has onboard charging at 500 milliamps, so you can just use a micro USB jack and plug it in. And this little yellow LED means it's charging. So you can leave it charging while you use the shield. It can be on or off. There's a protection diode and a fuse, so you don't have to worry about, you can have it charged and also program the Arduino through the USB port or whatever, it's fine. When you're done, you can just disconnect it. There's a LED that also goes on when the battery's fully charged, but I've been running this all day, so it will take a while. And then you can turn it on by flicking the switch. So you get a little on-off switch here. And then the blue LED turns on. There's also a red LED that turns on when the battery's low, but right now the battery's not quite dead yet. And that's it. It basically provides 500 milliamps of current at 5 volts, and it actually can provide 1000 milliamps. It can provide an amp, but I wouldn't draw an amp for a really long time. The battery, especially this size battery, doesn't like that much current draw for a significant amount of time. It reduces the battery life. I mean, you can do it. Basically, if you can run off of a USB port, you can run off of this. And I'll demo it, for example, with a NeoPixel shield. So you can just stack any shield you like on top. Hold on. So my demo uses a NeoPixel shield, and I can turn this off, and you can see it is glowing on the go. And then if you ever need to, you just turn it off, turn it back on, and it starts up again. So it's just like basically a portabilizer.
NeoPixel belt, finally, it's here. I can have, let's give you my belt. This is my belt buckle.
Okay.
This is my belt buckle. Look at this.
Yeah.
Give me my belt buckle.
All right. I think that's mostly all of it. I mean, it does require a little bit of soldering. You have to put the stacking headers on. But I think this will be really handy. I use this all the time now because I need to have portable projects.
Yeah.
And it's just because it's rechargeable, you can just leave it charged in until you need to use it. You can't charge the battery through the Arduino. You have to charge it through the micro USB jack. If you sit down and you draw out the diagram of how the power works in the Arduino, you'll see it actually isn't possible to charge the battery and also power the Arduino. There's only one pin that's shared. So instead, we charge through a separate port, but that's fine. And you can also unplug the shield, charge it, and then plug it in when you use it.
A couple quick questions on it. Does it work as a UPS charge and power the project at the same time?
Yep. If your shield, if the project uses less than 250 milliamps on average, it'll stay charged because the charge rate is 500 milliamps, and then you have to boost it, and there's a little bit of inefficiency. So about like 250 to 300 milliamps. If your project uses less than that amount of current, you use a charger doctor or whatever to measure it. It'll act as a UPS. But and not only that, but it won't use it'll automatically switch over from the battery to the from the power supply to the battery because there's a protection diode. So if you have it plugged in over a 9-volt connector and you unplug it, it'll automatically switch over to the battery. So you can actually just keep the battery charged, and then it only switches over to it when you need to.
Okay. And the other one was, is there any breakouts for leads that you can go into for connecting external leads? I think you meant external less, but I think you meant external leads.
External LEDs, there isn't. This is kind of meant to be all in one. I might make a revision. The thing is, there's not a lot of space because I wanted to not have anything collide with the battery. I might put some pads on the bottom later. You can measure the battery voltage through an analog pin.
Yeah.
Just use analog read, but there's no support for like external LEDs. Just use the on-board LEDs. They're really bright though.
Okay. All right. Next up, really big news. Adafruit is now a record producer. We have a very real album. It's called Frequency.
It's a real album.
If you like Adafruit music in all of our videos before our shows, all the things that sound like Adafruit, the cool electronic beepy music that you hear every time we show and share projects and have cool videos. This is a real album. It's limited edition. When they're gone, they're gone.
We're not going to do this again.
And
we're not that stupid. No,
yeah, when they're gone, they're gone. This took a really long time to do. The album title is Frequency. Let me tell you a little bit about this. This is your soundtrack to soldering. Tom White, our director of receiving and logistics, is a musician. And a long time ago, I told him, you're going to have a record one day. And he thought I was kidding. And I really liked his music. He's in a band with another group of folks here, Frog, and also in one called Little Anchor. The album art is Bruce Yan, our creative director, and this is it's a beautiful album. I've never seen pink vinyl, so let's.
You want to hold this up?
Well, yeah. Why don't you take the album off? We have a record player now.
Yeah, this is the album.
Yeah,
it's got an Adafruit pink and Adafruit black.
It's a real album. So this is.
You get the album.
Yeah. And the other thing is, all of the songs are Creative Commons.
And this is like PID 1600. So how long have we been working on this? It's been like
over 400 products ago.
Yeah, it's like been a year.
Yeah, so we have a record player, and we're going to just play it while we show some more stuff.
Let's start with side A.
Yeah, the other thing that we had to do at Adafruit is because we do so much content, it made sense for us to have an album because every time we have great content, when we first got going, YouTube would say, this is too good, you must not own it. And so now it's very clear that we have this album. So what I'm going to do is,
how are you gonna do this thing?
Well, I thought I would try to use the overhead as a camera since this overhead's been working out pretty nicely.
Hold on, and, let's configure this so that it's the
yeah, and so I can actually go up.
Oh, that adjusts. Okay.
Yeah, this thing is already earning its weight.
Okay, great. So this is lifted?
Yeah, and so the first thing we got to do is I'm going to try to focus this a little bit.
Okay.
There we go.
Okay. This is like 6 engineers required here.
Yeah. So we got a real record player. I want to show that this thing actually works.
Okay.
I bought this record player.
Okay.
And so now we're going to turn it on.
Okay.
There it is.
It's on.
And
so then you want to move it?
Yeah. So this is our record.
Oh, the speaker's over here.
Yeah.
All right. So
No, get here. We're fine.
Oh.
Yeah, this is like a giant CD for the young people out there. So.
Ah! Don't do
it's
that.
Okay.
Be careful. It's my album.
Yeah. you can move it over, and you can have it go down.
Yeah, see, nice lowering.
Okay. So if you want to listen to the music ahead of time, you can use the product page because we have it on SoundCloud. In usual Adafruit style, what we've managed to do
if
is
you don't have a record playing machine.
yeah, what we've managed to do, typical Adafruit style, is have it Creative Commons, and so you can listen to the music.
Yeah, and it's on SoundCloud. There's links. You can click on them. So you don't. I mean, you should download it and also buy the album because you have a record player most likely, or you found one at a swap fest or something,
Yeah.
and you want to rock out these tunes. It's excellent music. Tom's a great musician. Congratulations to him for his release of an album.
Okay.